problem. We have an inclined surface, straight surface, and actually we choose the x-axis along that surface. So what we do, we take a little ball and push it up along that surface, so it will roll up as much as it can and then go down. Also, we know that when at point A, at the distance w equals 2 meters from the initial point, at that point A, it will be 1 second from the beginning, and on the way back it will be 4 seconds from the beginning. So these three parameters we have given: the distance OA, 2 meters, time 1 second, time 4 seconds. What we have to find is initial velocity, acceleration, maximum displacement, time of maximum displacement, and the angle of inclination. Let's see. Initial time t0 equals 0 because we start from the beginning. x0 also equals 0. For this specific problem we choose, remember we have this standard formula for displacement. We choose that our displacement equals w. So in here, instead of x, we put w. Now our formula becomes this way. And what we can see is this is a quadratic equation where our independent variable is t, time. Now, incidentally, we have given roots of that quadratic equation, like solutions of that quadratic equation. So for let's look carefully. For displacement w, we have 2 times, 1 second and 4 seconds. Those are the roots of this quadratic equation. So what we can do here, we can use a Vieta theorem that says that the product of the roots is constant coefficient divided by leading coefficient, and the sum of the roots is the second coefficient opposite of the second coefficient divided by the leading coefficient. So let's write it down. Now we can see that in this equation we know everything. We know T1, we know T2, we know W, we don't know A. So this becomes an equation with just one variable, one unknown. Solve, and we get that acceleration equals -1 meters per second squared. Now let's plug in this -1 into second equation. Now this equation becomes equation with just one unknown, which is V0. Solve, we get V0 equals 2.5 meters per second. For x max, which is maximum displacement, we just use the standard formula. For t max, we also use the standard formula, which is, remember, acceleration by definition is change in velocity divided by change in time. So it looks like we found everything what we wanted. Now let's look at this problem from the point of view of functions. This is our equation of displacement. Let's plug in what we know. x0, 0. v0, 2.5. a, -1. Plug in, we get the quadratic function. Actually, for alpha, we can use this diagram, and we clearly see that sine of alpha is the ratio of a divided by g. So then we can solve this, and we get that alpha equals 5.7 degrees. For velocity, linear function, plug in v0 2.5, a negative 1, we get linear function. These are the graphs. We see that due to symmetry, final velocity when the ball coming down to the initial point will be just opposite of the initial velocity. The total time will be just twice of the time of reaching the highest point. Velocity when t equals 1 at this point, easily calculated from this formula here. Velocity at t equals 4, easily calculated from this formula of the linear function here. And velocity when we have the maximum point will be actually 0. It is easily calculated from here as well. Now we can see that if we use functions, it is like a higher level of understanding of this problem and this kind of problems. We have these two functions in a table format. So we have our independent variable time, and we have dependent displacement and velocity. So for any point of time, using these formulas, using these equations of quadratic and linear function, we can calculate displacement or velocity at any time.